We mainly worked on SAT, have we not? Did we ever work on ACT?
Yeah, like maybe once, not that much.
Okay. I've got a note here that the last session we had, we went through test 2 of the SAT. I don't want to start with the super hard questions. So how about we start with test 3? And my plan is to do exactly what we did before, 6 months ago, which is just to go through
Okay.
quiz questions. Now, the one thing that has changed is I know a little bit more about SAT than I did last time we worked together. I actually do presentations, 5-hour presentations on the SAT test for a company that does it to the area high schools, Sycamore Learning Company. So I might even be able to help you on the reading and writing part of the SAT.
Okay. Yeah, the one thing I liked about the SAT more was there were more tricks actually I could use to like shortcut the reading section
Yeah,
than there was.
there's a lot of things I've learned. Hold on one second. When I started doing this last year, I learned all kinds of things about both the ACT and the SAT, about the reading and verbal sections that I didn't used to know. So maybe not today because I've had the whole summer off, but I'm going to start back up and let me have a chance to review my SAT notes. And after I do, I'd be happy to do some online sessions with you on that part of it.
Okay, sounds good.
But as far as today goes, let's just start with the practice test 3. You see that okay, or do you, here, let me blow it up. Yeah, I can blow it up a couple times. Doesn't cost anything here. Oops. Unless I scroll too far. All right, how about number 1? We know it's going to be easy, right?
Yeah.
Despite the fact that it's 9 sentences or 9 lines long, we still know it's going to be easy.
Okay.
So all we have to do is review what they're telling us. Okay? What have they told us? They've told us that the fee is based on that. Well,
Yeah.
that's the number of walls. That's not going to be, that actually would be affected by a more expensive brand of paint. K is a constant with units of dollar per square foot. That probably is not going to be affected. L is the length of each wall in feet, and H is the height of each wall in feet. If the customer asks the painter to use a more, which of the factors would change? Wow. Because I see 3 of them that would change. And you can only answer one thing.
Yeah.
So given that, what would you answer? In other words,
And
it looks like the number of walls would certainly be a factor, right? I mean, that's going to,
yeah.
if you have 10 walls instead of 15 walls, then the more expensive brand of paint would cost you more dollars. Well, maybe. It depends really on the square footage. Right? So L is the length of each wall, eighth is the height of each wall. So both of those would definitely affect your price. The problem is that we only have 4 choices and we can only choose one. So our natural intuition is that yes, yes, and yes. So what does that tell you what the answer has to be? It can't be any of those other 3.
Yeah.
So it has to be K.
Okay.
And I can't even explain to you why. I don't get it. But perhaps the purpose of this question is to give you 3 answers that look like they're all correct. And since you know that only one answer can be correct, then those 3 can't be the answer. And the only one, we must be looking at it wrongly. So I'm saying K is correct.
Okay.
And I don't really know if that's true or not. I'll look at this problem further when I have a chance later. So let's go on, and I will examine that next time we meet. It's unusual that a problem number 1 is a hard problem, but maybe I'm overthinking that one. I don't know. So if 3r is 18, what's the value of 6r plus 3?
Uh, 39.
Yeah. Number 3 on the right over here. Which of those 4 expressions describes what that is equal to?
D.
Yes. Very good. Number 4.
B.
So if this number is twice the other number, and x is the other number, then the first number has to be twice x. So that looks right. X is the number, hold it, if 30, okay, 30 states joined between those 2 dates, and X joined between those 2 dates, and we know that, yeah, it's got to be B. All right. Number 5.
Can you go over? Could you review this one with me?
Yeah, let's try to solve that for x. And then once we solve it for x, we'll be able to easily figure out what x divided by 5 is. So how would you solve that?
Would you do 5 is equal
When
plus
you're
20?
looking at two denominators, think
Uh-huh.
cross multiply.
Okay.
In other words, I'm going to multiply that by that, and I'm going to multiply that by that. So what
Oh,
it
okay.
with is 15x equals 5 times x plus 20, which is 5x plus 100.
Okay, gotcha.
What's the next step of solving that? Kind of got to solve for x. We could solve for x over 5, but let's solve for x. It's easy enough to solve for x. Gather your variables on one side of the equation and gather everything else on the other side. So which side are we going to put the x's on?
The left.
So how many do I have over here?
20.
No, I got to subtract 5x.
Okay, yeah, so 10.
Get rid of it on the x. In other words, when you consider moving something from one side of the equation to the other, just do it and change its sign. So if I want to move that 5x to the left side, I do it and call it minus 5x. Which gives me 10x on the left, 100 on the right. What's x equal to?
10.
What's x over 5 equal to?
2.
I don't know if these tests are representative of the actual problems you get on the test, but I do know that every test we do, all of these medium problems, they have like 3 steps, and you got to know 3 different math principles to accomplish each one of them. And that's a good thing. In other words, what we're really doing here is reviewing all of algebra and geometry, mainly algebra. And incidentally, in case you're wondering, one thing I do know is that the SAT test is 80% algebra, 20% geometry. The ACT test is about 50-50. So if you find yourself doing better on the SAT test, it's probably because you're better at algebra than geometry. Or, excuse me, yeah, you're better at algebra than geometry because most of the SAT test is algebra. Notice we've done like 8 problems here, and we haven't seen a geometry problem yet.
Yeah.
So, and some of that might be the fact that it's probably been a couple of years since you took geometry, right? I mean,
Yeah.
what are you taking this year in terms of math?
Precalculus honors.
Okay. So last year you took Algebra 2, and the year before that you took geometry, right?
Yeah.
So it's been at least 2 years. And that's why
Yeah.
people tend to not do so good on geometry once they get to these tests because, you know, they took it in 10th grade or 9th grade in some cases. So it could be worthwhile to review more geometry, although if we're practicing for the SAT, then we want to review 80% algebra.
Right, okay.
Okay, so number 6. This covers all subjects in Algebra 2. It really does. There's actually an easy way and a hard way to do this problem.
Okay.
as with most problems, is they always give you, if you are smart enough to spot it, they give you a quick and dirty method of solving it that only takes like 15 seconds. Whereas if you do the more traditional way, it might take you a full minute.
Okay.
So first of all, let's do it the traditional way. We got two equations here. You're going to use substitution or elimination?
Elimination.
One, that's equation 2. These two equations are in standard format. In other words, the left side is x and y, the right side is a number. Whenever you're looking at two equations both in standard format, elimination is almost always the way to go. It's absolutely the simplest way to go. Now, normally, by elimination, I would have to eliminate one of these variables. So I might have to multiply the top by 3 and the bottom by 2, and then subtract the two equations.
Right, okay.
Notice they're not asking you for x and y. They're asking you for x minus y. So what happens if you subtract these two equations? As is. What do you get? Subtract.
Negative 1x. Plus 1?
No, it's minus. I have a
minus
3 minus a minus 2, which makes it minus 3 plus 2. So that's minus y. And then minus 14 minus a negative 6 is a minus 8. So this did not come out the way I hoped it would. I hoped that it would come out either x minus y or y minus x. Notice that had it been y minus x on the left and it comes out to be negative 8, then I know that x minus y is positive 8. But because it comes out to be that, you really cannot determine anything from that. In other words, that is not x minus y, and it's not y minus x. In case you're wondering, a minus b is always equal to negative 1 times b minus a. So if it comes out to either one, you're going to know the answer.
Right.
But unfortunately, when it comes out to minus x minus y, even if I factor out a 1, I get x plus y equals minus 8. So I could tell you what x plus y is, but I can't tell you what x minus y is. So it turns out that the quick and dirty method of solving this is not so quick. In other words, we got to do it the hard way, which is to figure out what x is and figure out what y is, subtract them, and we'll have our answer. So, what's the normal way of solving this?
Well, you use elimination.
Okay, what's the next step?
Multiply the top by 3, the bottom by 2.
Okay, that gives you 6x minus 9y equals minus 42. And the bottom by 2 gives you 6x minus 4y equals minus 12. Now this is the new number 1, that's the new number 2. Now what are we going to do?
And then you can cross out x because those cancel.
Are we going to add or subtract?
Subtract.
Exactly. Because these signs are the same, the only way we're going to eliminate anything is by subtracting. The Problem with that is that we're looking at 5 negative signs. Very easy to make a mistake. So perhaps when we did this first step, we should have done that by 3 and this by minus 2. Notice what happens. Instead of 6x, it becomes minus 6x, becomes plus 4y, becomes plus 12. And now we don't have to do any subtractions. All we got to do is addition. In other words, now if I add the two equations, what do I get? Addition is always easier than subtraction, no matter who you are.
Yeah. So then you just have negative 5y equals negative 30.
Y equals what?
6.
Now I got to know x also. So which equation should I use to solve for x? One of the easier ones. One of the ones that I didn't multiply by. In other words, almost never the new equation 1 or 2, but always the one of the original ones. So how do I solve for x? Pick an equation and solve for x.
Okay, top equation.
I would choose the bottom one only because minus 6 is less than minus 14.
Oh, okay.
So you always want to choose the equation that is the simplest. So I'm going to use this equation to solve for x. What do I do?
Okay. Plug in 6 for y, so 3x minus 12 equals negative 6.
What is x minus y?
Well, then you would take
Hold on.
add 12.
Hold on. We've already solved for x. When we solve for y, we want to know what x minus y is. What is x minus y?
Oh, sorry, you already did. Never mind. Okay. Okay. X minus y, that's negative 4.
Yeah. And notice that if you didn't go through all of that work, the most likely answer you would guess would be 8. Because it almost looks like you can just kind of subtract those two equations and you're going to get x minus y equals 8 or negative 8, right? The problem is you don't get x minus y. You get minus x minus y. And that actually does not ever relate to x minus y. If you got y minus x, that'd be a different story. If I switch this and make that equation, hold on a second, just saw something here. We call that 1 and that 2, and we do 1 minus 2, well, we get minus 2 minus a minus 3, so you get y, and you get 3x minus 2x, so you get y minus x, and then minus 6 minus a minus 14 gives you that. Ooh. Wow. I must have done a mistake here. Minus 2y minus 3y is plus y. And 3x minus 2x, that's y plus x. So again, it does not advance. Knowing what y plus x is does not help you figure out what x minus y is. So if you try to, the extra smart student's probably going to miss this question because they're going to either answer 8 or minus 8. But if you do the question the hard way and the long way, you get the correct answer of minus 4. So this is one of those fake traps where it looks like the quick and dirty method might be the better way to do the problem, but it really isn't.
Okay.
Let's look at number. What's another term for f of x?
Function
Y.
of x?
Y. In other words, y and f of x are interchangeable. In other words, this could be called x and y or x and f of x. What f of x means is y.
Okay, yeah.
So, this function appears to be, first of all, it's not linear. Let's talk about this for a second, because this is kind of an abstract math concept. If you're trying to figure out a function, what kind of function it is, if it's linear, then the distance between that and this is going to be the same at every interval. In other words, the distance between that and that is 2. Distance between that and that is minus 2. But then when I go from here to here, it's plus 2. And when I go from there to there, it's only minus 1. So it's not linear. And the only other functions that they really expect you to know are quadratic. So my guess is that f of x is going to be some form of this. Well, how about if f of x was equal to that? Then that would be true. But when x is 2, that would be 7. So this isn't the right function. How about this? I see another function, and I don't know if anybody can expect you to figure these out, but if x is 0, f of x is 3. If x is 2, f of x is minus 1. So that's not right either. So let's examine the question. The question says is what must be a factor of f of x? Well, all of those factors are what you would get from factoring a quadratic, correct?
Yeah.
So, wow, this is a tough question. Must be a factor. That means that one of these times f of x, in other words, could f of minus 2 times f of x be equal wow. Think for a moment. All right, so here I've come across a problem that I don't know what to do. So let's try a couple things. What would be your first step? I mean, if your life depended on it and you had 15 minutes to solve this problem, what would you do next?
I'm not sure.
Well, how about we attempt to multiply a couple of these things together? Let's multiply that times that. What do you get when you multiply that times that? Just a shot in the dark. In other words, I really am at a total loss, but I think I can figure the problem out if I just start playing around with some of these. They're saying they're looking for factors of f of x, so let's assume that maybe both of these are factors just to get us going. Okay, if I multiply those two numbers together, I get this. So is that f of x? Well, now we can put it through the test. When x is 0, what is f of x?
X is 0. 6.
So that's not the right answer.
Yeah, 3.
But, and obviously only one of these is going to be correct, not two of them. So, why am I even multiplying it by that? I kind of know that 3 might be my constant. Why do I know that? Plus 3. Which would have to make that that. In other words, just as I shot in the dark, I got to come up with a quadratic where this is true. That first row is true. And then I'll see if that quadratic is true for the second row and the third row and the fourth row. Is this quadratic that I just picked out, is that true for that first row?
Yes.
Yeah. Is it true for the second row? Maybe I got lucky.
No.
No, it's -1, isn't it? So we would have 4 minus 8, which is -4, plus 3 is -1. So this is not the correct quadratic. I got to come up with a quadratic that one of these factors is the factor, and it's got to be close to this constant. I know that when x is 0, that takes care of the first term and the middle term, that the third term has to be 3. So I've got to have something that looks like this, plus 3. Well, if I try to figure out what could possibly go in there, I could put plus 4x. That doesn't satisfy the second row. What else could that be? -3 times -1. That doesn't satisfy the second row. What else could go in the middle to give you that? -2x. And no, then this would have to be -3. I don't know. This problem has me baffled. I've gone through all my techniques, and I'm going to pass on this and come back to it later.
Okay, so this would be like one with like 3 check marks.
Take a look at it, and we'll hopefully by the next time we meet, I'll have it solved as to what the best way to approach this problem is. But in the meantime, let's not waste our valuable time here, and let's go on. Number 8. We can tell the problems are getting harder.
True.
This is not really a pure algebra. I guess it is. It depends on whether you call the XY plane algebra or geometry. Actually, most people probably call it algebra. So let's draw the XY plane. This is the y-axis. This is the x-axis. The line is kx plus 4. What's its y-intercept? Here's our line. What's the y-intercept?
-4?
It's plus 4, exactly. In other words, we don't know much about this line, but we know it crosses that point. And we know its slope is k. It's just we don't know if k is positive or negative or whatever. But it also contains a point CD. So we'll just draw that. Even though we don't know for sure that the slope is positive, we'll pretend it does for a moment. Now, if the line were to be as I drew it, what's the slope of it? How do you figure out slope? Slope is what? Verbal.
Oh, the formula for that?
No, verbally. The best thing to remember is verbal. Rise over run.
Yeah.
Okay. Well, what's the rise?
4.
The rise is the difference between that y-coordinate and this known y-coordinate. So the rise is d minus 4. What's the run? The run goes from C to 0. So what's the run?
C.
So, if the slope is positive, this is the answer. With me?
Yep.
What if the slope is negative?
It'd just be reversed, wouldn't it?
Well, what would that mean? Does that mean this would be the answer?
No.
Can't be, right? Because we don't know if the slope is positive or negative. Therefore, the fact that we assumed it was positive and came up with this as the answer means that even if we made it negative, it's still got to be the answer. Because if something else was the answer, this would be an impossible question, right?
Yep.
Let me prove it to you. And it's kind of an important consideration on the SAT is to understand that they only have one answer that is correct. So let's assume the slope is negative. What is the slope of the blue line? What's the rise?
That would be, yeah, the rise. 4 minus D.
What's the run?
C.
Nope, it's 0 minus C. In other words, if you do slope, you always have to go in the same direction. If I'm going to go y sub 1 minus y sub 2, then I got to go x sub 1 minus x sub 2. Well, guess what that's equal to? The same thing as the top, d minus 4 over positive c. As it has to be. Because otherwise there would be two correct answers to this problem depending on whether our slope is positive or negative. and they refused to tell us whether it was positive or negative. What that tells me is that I can assume it's positive, and whatever I get, that has to be the answer. Because if it's negative, it can't be a different answer. Otherwise, I would have two possibly correct answers. And that is never the case on these tests. Whether it's the ACT or the SAT, you always only have one answer that's correct on the math. Now, it's a little different on the verbal. On the writing and the reading on the SAT, frequently you have two answers that one could consider correct. And you have to choose the best one of the two. But never on the math. On the math, there's only one correct answer.
Okay.
This is really an excellent problem. I mean, it really shows you that principle. And it took us 5 minutes to do this problem. If I had to rely on the fact that, well, I got to test both positive and negative slopes. But the fact of the matter is that once I come up with an answer for a positive slope, that has to be the correct answer. Because the slope, obviously, k is a constant. We have to allow it to be positive. And if it's positive, then this is the right answer. If it's negative, there can't be another right answer. That would give me two possible answers. So this is a great problem. We can also see that it's getting difficult fast.
Yeah.
We're only on problem number 8.
How many problems are in this section?
I'm not sure. I think 20. Let's see. This is the no calculator portion. There are 15. And then there are 5 questions that are grid in. And then there's some number of questions more that are calculator questions. But this section is no calculator. So we're about midway through 15. So we should be into medium hard question. And that one, well, that one really tested your knowledge of slope. I mean, you could have done that the hard way and tested both positive and negative slopes and realized that they both produce the same answer. Or you could cut your time in half by solving for a positive slope only and realizing that it had to be the same answer as the negative slope. Otherwise, they would have given you 2 answers on a problem. You know they don't do that.
Sure.
All right. Number 9. I want to talk about simultaneous equations for a second. When you have simultaneous equations, you either have a unique solution, solve that, how would you solve those 2 equations?
You could use elimination.
Always. That's an automatic. Whenever you have both equations in standard format, you're going to use elimination. So what's the next step? Got to eliminate a variable.
You could easily eliminate y.
By doing what?
Multiply.
No, by adding both equations. By adding one equation to the other. That's always a permissible process, is by adding 2 equations. If I told you a plus b is equal to c and x plus y was equal to z, then you could add those 2 equations and you get a plus b plus x plus y equals c plus z. That's always allowed. So when you add these two together, you get 2x equals 20. You get x equals 10, which means y equals 0, correct? That is the only solution to these two equations.
Okay.
Now, let's change the problem just a little bit. And if I told you that x minus, let's make it easier. Let's say x plus y equals 10 and x plus y equals 9. Now solve.
So you would still use elimination.
Okay, what are you going to do? You're going to add or subtract the two equations?
I'm
going to subtract them. I get 0 equals 1. Well, 0 is not equal to 1. It never is equal to 1. So what that tells us is that these two equations are impossible. That is no solution. Okay? Because I got 0 equals, I get one number equal to a different number. That is never possible, ever. Now, let's take a third look. X plus y equals 10. 2x plus 2y equals 20. Solve that.
So it's still using elimination?
Always. Whenever I give you two equations where they're both in standard format, always the easiest way is elimination, never substitution. The only time you want to use substitution is one of the equations is already solved. In other words, if the top equation was x equals 10 minus y, that's a different story.
Okay, gotcha.
Substitution is the easiest way. But as long as they're in standard format, that is, always use elimination. So what are you going to do to eliminate a variable?
Multiply the top by -2.
Okay, that gives you this. Minus 2y equals minus 20. Now you add them all together and you get 0 equals 0. This gives you infinite number of solutions. In other words, notice that I wasn't able to solve for x or y. I do get a number equals to another number that it's actually equal to. So there is a solution. It's just that all x and y work. And the reason they do is because these are not separate equations. Is all I did to get the second equation was multiply the first equation by 2. That's what I did. So I have not added any information. Is all I really have here is equation number 1 twice. And when you have only one equation and two variables, you cannot solve it. There are literally an infinite number of solutions. Okay? So that's what we're looking for when we have these simultaneous equations. We're looking for one of three cases. We get x equals number, y equals a number, that is a specific solution. We get some number equals a different number, that means no solution. Or we get 2 equals 2, that means infinite number of solutions. Okay?
Okay.
Let's finish this problem. This is perfect. Remember those three situations. And if we look at this problem, it is saying to us, what value of k would the system have no solution?
Oh, okay.
Now, this is harder than it looks. I mean, I gave you Simultaneous Equations 101 just now, but this clearly does not have a simple solution. All of our answers, if we look at all of our answers, notice what we're looking at. All fractions. So what's the best way to proceed? In other words, you got to know what I just taught you, those three different types of situations. We're looking for no solution, meaning we're going to end up with some number equals a different number. It doesn't have to be 0 and 1. It could be 1 and 2, 1 and 3. It just means that these numbers aren't going to be equal to one another. So what can we do here? I don't know what to do next. But if somebody had a gun up to my head and said, solve this problem or you die, what would I do? You'd start trying each solution.
Yeah.
Let's
so this
is one. Let's see what happens when I try that for k. Well, I get 12/5 x minus 3y equals 4. And this is 4x minus 5y equals 7. You see, follow it? You following me?
Yep.
Okay. Now, it's not real easy to go from here, but how about if I multiply the top by 5 and multiply the bottom by minus 3? You see why I would do that?
Yes. Yeah, I got it.
Give me a 12, and that's the coefficient of x, and it'll give me a minus 12 of the coefficient of x down here. So what that gives me is the following. 12x minus 15y equals 20. It's multiplying the top one by 5. Multiplying the bottom one by minus 3 gives me this. Now, if I add those two equations, I get 0, right? Equals minus 1. That's what I'm looking for. Is one number equals another number. That means no solution. Bingo, I found my answer. And trust me, it was no accident that it's answer A.
Okay.
Why? Because this is really the only way I can think of to do the problem is by back solving. In other words, I'm going to try A, I'm going to try B, I'm going to try C, I'm going to try D, until I find where I get one number equals a different number. And each number takes hard algebra to solve. So if answer D was the correct answer, this would be a 5-minute problem. They do not give you 5-minute problems. So the fact that they made answer A the problem is not accidental. Anybody that does this question properly and then back solves it immediately gets the correct answer. So it actually becomes only a 1-minute problem. And that's acceptable. So when you have a problem like this and you know you have to back solve it and you can see that, oh my God, the back solving is going to take me 10 minutes to do, understand that it's highly likely the very first number you try is going to be the right answer. If not that, then I'm going to try that one. And if not that one, then I'm going to try that one. And if none of those three work, then I'm going to assume that D is correct and I'm going to go on. So the most number of trials I'll have to make is 3. But you can
Okay.
see that all of them are tough because we're dealing with hard fractions here. These are not easy fractions. So to solve these equations the way we normally do, notice what I had to do. I had to multiply that by 5 and that by 3. Well, that's difficult. That's not normal. That's extra hard. But that actually produced the winning answer immediately.
Okay.
All right, let's stop there, Ben. And let's see, are we going to do this every set? When are you taking your SAT test?
October 6th.
So we got a little more than a month. Are we going to do every Saturday?
Yeah, I think so.
You want me to go ahead and schedule it?
Yeah, definitely.
At what time?
Um,
You want 11 or 2? Either one is fine.
I think 2 sounds good.
All right, here, let me make this a recurring appointment at 2. It ain't gonna let me do it. I'll have to do it manually. But that's okay. I'll put you down for 2 o'clock every Saturday up through October.
Okay, sweet.
All right. Ben, have a good week. I'll talk to you next Saturday.
Great, thanks, you too.